Hello, YouTube. This is Mr. Bakari, and today we are going to talk about the dot product. We're also going to include finding the angle between two vectors and the orthogonal test. That is, to find if a pair of vectors are orthogonal or perpendicular with each other. So let's get started. Okay, so there's two kinds of vector multiplication. There's that where we can get a number, which is the dot product. That's what we're going to be looking at today. And there is the cross product where our product is a actual vector. That you will find in later courses like Calculus 3. Okay, so what is the dot product? The dot product measures directional similarity, how much two vectors line up. Okay, so if you look here in blue, it pretty much gives you the how to. So we've got two vectors, v and w, okay, with components AB and CD. It says take the product of A times C, take the product of B times D, and then add those two products together. So what you're going to end up with is a numerical value, just one number, and that is the dot product. Okay? Now, what does this dot product tell us? So if you look over here on the right in the box, if your dot product is a positive value, then the vectors point roughly the same way. So they would make an acute angle or possibly even parallel. If they are zero, if the dot product is zero, then the vectors are perpendicular or what we call orthogonal. And if the dot product is a negative value, the vectors point opposite ways, so they create an obtuse angle. Okay? So let's look at these three examples. We've got two vectors here, and we're going to find the dot product. So we are going to take the change in x and multiply those. We get 21, take the change in y, 8, add those two products together, and the dot product is 29. So that's a positive value, which tells us that these vectors point roughly the same way. Okay, the second one, we take the change in x, which is 25, the change in y, which is 1, add those together. Again, we get a positive value. Our dot product is 26. The last one, we've got 8 times negative 3, which is negative 24. And we've got 6 times 4, which is 24. Now here, we add those together, we get a dot product of 0. So that tells us that these two vectors are orthogonal. Okay, they're perpendicular to each other. And that's how it works. All right, so there's some questions that typically are asked when the dot product is introduced. Like, here's a pair of vectors. Are they parallel? Are they orthogonal? Or are they neither? Okay, so like we discussed here, if the dot product is 0, they are orthogonal. But if you get a positive dot product, that doesn't necessarily tell you that they're parallel. If you get one that's negative, it doesn't necessarily tell you that it's parallel. So what we need to do is we need to look at the slopes of the two vectors. So remember that the components here are change in x and change in y. So if we take the change in y and put it over the change in x, we have a slope. All right, so we're going to look at these two slopes. And if you remember from Algebra 1, if they are the same slope, they are parallel. And if they are negative reciprocals of each other, they are perpendicular. So there's our orthogonal right there. So we actually don't even have to use the dot product for this exercise. Okay? As long as these are two-dimensional vectors, then this is going to work. All right, so we're going to take the slope of the first one, which is negative 1/2. Remember, it's y over x, and 2 over 1. Okay, what is the relationship here? Well, they're not the same, but there is a specific relationship here. They are negative reciprocals of each other. So therefore, these two are orthogonal. Okay? Let's look at the bottom two. So here, the slope would be 7/5. And over here, negative 21 over negative 15. What's the relationship? Well, if we simplify negative 21 over negative 15, we simply have 7/5. So these have the same slope. These two vectors are parallel. And obviously, if they're not orthogonal, they're not parallel, they are neither. So that's basically everything else. Okay? All right, let's look at this question. This includes some concepts that we learned prior. Okay, so it says find a vector that is orthogonal to the vector 2i minus 3j and has a magnitude of 6. Okay, so first of all, our vector that's given is in I and j form, sometimes called standard form, and we want a magnitude of 6. So the first thing we're going to do is, since we're looking for an orthogonal vector to 2i minus 3j, we want to see what is the slope of this. So that's negative 3 over 2. So if I want to write a vector that is orthogonal, I'm going to take the negative reciprocal, which would be positive 2/3. All right. So if I write that in the form ij, then my vector will be 3i plus 2j. Okay, so this vector is orthogonal, but I want to have it have a magnitude of 6. So what I want to do is I need to find the magnitude of this vector. So remember, as we recall, to find the magnitude, we are going to use the distance formula. So we're going to take the change in x and square it, add it to the change in y squared, and we're going to take the square root of that. Okay? So what we get is square root of 13. All right? So if the magnitude of this vector is root 13, we can take these components and divide them by root 13, and we create a unit vector. That is the vector that runs the same direction but has a magnitude of 1. And once we have a unit vector, we can then multiply that by any scalar. In this case, we'll multiply it by 6. And now we have a vector that's going to be orthogonal and have a magnitude of 6. So our final answer would be 18i over root 13 plus 12j over root 13. All right. Okay, so these ideas typically go with dot product when the dot product is introduced in your course. All right, I want to finish up with finding the angle between two vectors, okay? This includes dot product, and you'll most likely learn this at the same time. So what I have over here is a coordinate plane, and what I'm going to do is I'm going to do a rough sketch of these two vectors on the coordinate plane. Okay? I'm going to graph the first one. I'm going to start at the origin, and as you can see, the components say -4, -7. I'm going to go left 4 and down 7. And there's my first vector. So my second vector, I'll change the color. I'll go to the origin, and I will go left 2, down 9. So there's my second vector. And what we want to do is find the angle in between them. Now, it's always good to get a rough sketch going so you can see that this is obviously going to be a very small angle, as you can see. So it's good to know that ahead of time. Now let's look at this formula. The formula is cosine theta equals w times v. That's our two vectors. So we'll just call this one w and this one v. And if we multiply them together, that's going to give us the dot product. So cosine theta equals the dot product of the two vectors divided by the magnitude multiplied by the magnitude of the other vector. Okay, so these pair of vertical lines mean magnitude. We're going to multiply the magnitudes on the bottom. All right, so let's set this up to put this in our calculator. Now, we are looking for an angle, so we are going to use inverse cosine. All right, so let's find the dot product. So I'm going to multiply my change in x. I get 8 Multiply my change in y, I get 63. 63 and 8 is 71. All right, so I'm going to take inverse cosine, and I'm going to divide 71 over the magnitudes multiplied together. So let's find the magnitudes. So my first one, negative 4 squared plus negative 7. Remember, magnitude, throw it into the distance formula. So here we have 65. Square root of 65 is our magnitude. Okay, we're going to multiply that by the magnitude of v. So that's going to be negative 2 squared plus negative 9 squared. And that's going to give us the square root of 85. All right, so there's our setup. Now we can put this into our calculator. I'm using a TI Inspire, and I want this in degrees, so I'm going to make sure I'm in degrees, and I'm going to hit inverse cosine, and I'm going to divide 71, which is my dot product of the two, and divide that by the magnitude of 65 times the magnitude square root of 85. Everything looks good. Enter, and I get 17.22 degrees if I am going to round to the nearest hundredths place, which is my typical go-to. So 17.22 degrees. Now look at the angle. Does that make sense? Does that look logical? It does. That is how you find the angle between two vectors. So I hope this helps you out, and I will see you in the next vector video.